The internet is probably the biggest thing to happen since computers were invented, and it is what pushed computers way beyond their limits and beyond what anyone could have imagined. Google, the search engine, gets about 3.5 billion searches every day. That's about 40,000 searches every second. Crazy, right? And YouTube, where you're watching this video, has about 500 hours of video uploaded every single minute, and around 5 billion videos are watched every single day. The internet is what connected billions of people worldwide, making it possible to share information no matter where you are. But, as they say, with great power comes great responsibility. About 50% of internet users have shared personal information online, like their name, location, or phone number. But you might wonder, what's the big deal with that? Well, your internet service providers or your web browsers can track everything that you do online. They can keep a history of the websites that you visit, track your activity on them, and then link all that information to your IP address, creating a complete profile of you. Your IP address is basically like your local address, but online. All this data gets sold to advertisers, who then show you ads based on what you search for and what you do online. This is a big concern because it's a serious invasion of your privacy and a total exploitation of your personal info. So this is where our savior, a VPN, comes in. The purpose of a VPN is to provide a reliable, secure, and encrypted connection between computers over the internet. You've probably used a VPN to access data or websites that are blocked in your region, but there's a lot more a VPN can do besides that. In simple terms, a VPN hides your internet activity by encrypting your data so no one can see what you're doing. Imagine you're trying to cross a border that is being guarded by soldiers. You can't just walk through because you'd get attacked. But what if there was a secure path, like an underground tunnel or something, that lets you cross without being noticed? Well, that's what a VPN technically does. It creates a private tunnel between you and the server, keeping your online actions hidden. One of the best things about it is that it hides your IP address, keeping your location anonymous. Now, as long as your VPN doesn't keep logs, which some do, it makes sure your online activity stays private. Further, there are some cool uses of a VPN on top of its security. Like, if you've worked at a software company, they might make you use a VPN to connect to their network. That's because companies often have sensitive data and internal tools that only authorized employees should access, especially if you're working remotely. So, they use corporate VPNs to connect you to their network, keeping everything secure. Now, even if you're working on an insecure public Wi-Fi, the VPN keeps your connection safe from attackers, and hence, you can access the company's servers, databases, and internal tools as if you were in the office. Another cool use is if you have a self-hosted server or something. You can set up a VPN to access it from all your devices. Now, if you're away from home and need to reach your server, just connect to your VPN and you can use it like you're right at home. Sounds cool, right? But how does a VPN actually work? A VPN acts like a middleman between your computer and the server that you want to hit, and thus allows secure communication between the two. When you're using a VPN, your requests are encrypted using a secret key. This key is only known by your computer and your VPN server. What actually happens is that your request has packets of data that need to be transferred from one place to another. To keep these packets secure, a VPN uses something called encapsulation. Encapsulation is the process of wrapping a packet of data in an additional packet, which includes control information such as routing and security details. This additional packet ensures that the original data can be transmitted securely over the internet, protecting it from being intercepted during transmission. Once it reaches its destination, the outer packet is removed, allowing the original data to be accessed. Now, to transfer these packets securely, VPNs use tunneling, which is just a fancy way of saying that your data gets packed into a secure tunnel so it can travel safely across the internet. The devices at both ends of the tunnel can encapsulate outgoing packets and reopen the incoming ones. This makes sure that even if someone manages to interrupt your request, he won't be able to get the data. Normally, when you browse the web, you send a request directly from your computer to the website's server, and the server sends back some data. But this isn't completely secure because your ISP can see what websites you visit. With a VPN, your request is first encrypted on your machine and sent to the VPN. The VPN then decrypts it and passes it on to the website's server. When the server sends back the data, the VPN encrypts it again and sends it back to your computer where it gets decrypted. Now, even if your ISP tries to track your request, all they will see is that the request went to the VPN server and not the actual website you visited. The same happens with the server when it responds with data. The data gets sent to the VPN, and hence the server doesn't know anything about your computer. This way, both the ISP and the server don't know where the request is coming from or where the request is going to. VPNs also hide your IP address by replacing it with one that belongs to the VPN, which lets you browse anonymously and keeps your location hidden. To make sure everything runs smoothly and securely, VPNs rely on various protocols or rules for transmission of data, and one of the most modern and widely used protocol is WireGuard. WireGuard stands out because it's lightweight, thus it's faster while still doing a great job with encrypting your data. But remember, the security of the VPN itself is super important. If the VPN isn't secure, your data could be at risk. There are plenty of free public VPNs that you might have used before, but they aren't always secure. These VPNs store logs of a user. Logs record information about what sites you visit and the requests you make. While most VPNs claim to follow a strict no-logs policy, some still do track your activity. If a VPN provider keeps logs, your privacy could be at risk. If someone gets access to these logs, he can see your browsing history and even some of your actions online. Things get tricky with free or public VPNs because the provider has control over all the traffic passing through their servers. Also, most of these VPN services are closed source, meaning you don't know what's happening behind the scenes. If the provider isn't trustworthy, they might be selling your logs. Not every VPN does this, but with public VPNs, you never know. So, what's the solution? One option is to use a reliable VPN on your own server. Now, I know that setting up your own server sounds difficult. You can rent one from cloud platforms like AWS or other providers. This way, you control your own data, and it adds an extra layer of privacy since you're not relying on a third-party VPN provider that might log your activity. Alright, now let's talk about making your own VPN. You might want to make your own VPN for better security, or maybe you're like me and just want to make one for the fun of it. Making your own VPN is a great option if you don't trust the free providers. So allow me to introduce you to Tailscale. Tailscale lets you create your own private network for your devices. It lets all your devices securely talk to each other over the internet, no matter where they are. Please keep in mind that Tailscale didn't sponsor this video. I genuinely think their service is awesome for something like this. Now, Tailscale has some really cool features, unlike other providers, like instead of needing a central server to route traffic, Tailscale uses something called a mesh network. This means that all of your devices connect directly to each other. It's as if they're on the same local network, even if one is at home and the other is halfway across the world. Each device gets its own private IP address, and all your data is fully encrypted. One of the main features of Tailscale is that it is super easy to set up. Hence, you don't need to worry about setting up complex configurations. It just works out of the box. With Tailscale, there's almost no setup required. Just install it, sign in with an account, link your devices, and boom, you've secured your network. Now that's all good, but what about a traditional VPN which lets you change your location? That's where an exit node comes in. An exit node lets you route your internet traffic through one of your devices, which works like a traditional VPN server. What happens is that you flag one of your devices as an exit node, and now all of your devices in the mesh network can connect to it. If you decide to connect any device to this exit node, all the traffic of that device will be exposed through it. If we connect a machine to our mesh network that is quite far away from our actual location and flag it as an exit node, it will act and work as an actual VPN. Now, let's go ahead and deploy our own VPN. To do that, we will need a cloud platform to host it online. And this is where Zerops comes in, the sponsor of today's video. Zerops is a cloud platform that takes care of building, deploying, running, and managing your apps, no matter how big or small your project is. If you want a platform that's easy to use, affordable, flexible, and lets you easily scale your app when needed, Zerops is a great choice. One of the best things about Zerops is how you can quickly adjust the size of your app based on what you need, making it super flexible. I use Zerops for my everyday projects because it's fast and easy to deploy all my projects. What makes them stand out is their super affordable pricing, which beats most of the other providers while still providing the best service. If you're looking for a reliable platform to manage your apps, go ahead and give Zerops a try. If you sign up now, you will get $15 of free credit, but what I would suggest is you buy just $10 of credit and use my code StupidGeek to unlock additional credit worth $75, giving you a total of $100 of credit. Isn't that a crazy deal? Let's actually go ahead and deploy our VPN on Zerops. So after signing up, go ahead and create a new project. Give it a cool name and click on the Continue button. Now choose a Linux container for your VPN. Here, I'm going ahead with Ubuntu. Choose a name for your container, just like when you install Linux. Then click Add Ubuntu, and congratulations, you've got your own server hosted and ready to use. Now we gotta access this container from our computer. So let's set it up locally so we can actually start doing stuff on it. Head over to the Zerops docs and look for ZUD-CLI. It's a great command line tool that lets you access and manage Zerops services right from your terminal. You can set up servers, deploy apps, and more, all from the command line. Go ahead and install it based on your operating system. Now, we need to log in, so head over to your profile, click on Access Tokens Management, and grab your token. Now, in a terminal, type in ZCLI login, and then paste your token. Now we're ready to set up our VPN. Let's start by creating a new folder. This will serve as our Git repository to track and build the container. Go ahead and open this folder in your favorite editor. Firstly, initialize a Git repository in this folder. Now, to configure the container, we need to create a configuration file. This file will help build the container, and we can add any additional settings or custom configurations according to our needs. Head back to your project and copy the default configuration file. We'll keep things simple and stick with the basic setup since we don't need much for our server, but feel free to add any extra configurations if you need them. Now, go ahead and push this configuration to Zerops. Choose your project and service, hit enter, and wait for the container to build. Remember how I said that companies use their own VPNs to connect you to their service? Well, Zerops uses something similar to connect you to their containers. If you run ZCLI VPN up, you will be prompted to select a project which you want to connect to. Make sure you have WireGuard installed on your PC, because this might throw an error here if you have not. I have it installed already, so my VPN connects without any issues. Now we need to SSH into the Linux server that we created, so go ahead and type SSH and the name that you gave to your server. And congratulations, you now have access to your online hosted Linux server on your own machine. Now let's go ahead and set up tailscale. Go ahead and sign up. After signing up, you will end up on this screen where you will be asked to connect your devices to form a mesh network. Tailscale has good documentation, so it's really easy to set up all kinds of devices. Let's set it up on our Linux server. Just copy this installation command and paste it on the terminal. This will install Tailscale on our server, and we should be good to go. Now we need to log into Tailscale on our server, so if you run sudo tailscale up, you will get a link where you can do the same. Go ahead and log in with the same account that you used before to sign up. Now, if you go back to where we copied the installation string, you can see that our Linux server is listed and is waiting for other devices to form a mesh network. Now, similarly, go ahead and install Tailscale on your other devices and add them to the mesh network. If you did everything correctly, you should land up in this dashboard where all of your connected devices are listed. Notice how every device already got a new IP address limited to the mesh network. This IP masks your original IP, protecting you from potential attacks. Moving forward, we need to advertise our server as an exit node as we discussed before, but you will notice that the option to use a device as an exit node is grayed out. This is because we need to manually flag devices as exit nodes on servers. So let's use this command to change our server to an exit node. Just paste this command in the terminal and we should be good to go. After using the flag, we can see that the option isn't grayed out anymore, and if you check back on the dashboard, you will find the server marked as an exit node. Now let's actually go ahead and check if our VPN is working. If you open up Tailscale and go over to the exit node section, you will find the server that we just created. If you click on it, you will be connected to the exit node within seconds. But we don't know if the exit node is actually working or not, right? So let's go ahead to what's my IP address to check our IP and location. You can see that my location is somewhere around Europe, which is definitely not the place that I am from. So seems like our VPN is working as expected. That was it just for a VPN, but Tailscale has additional features other than what we discussed before. And one of the main features among them is how easily you can share files across your mesh network. Taildrop, which is an inbuilt feature, lets you share files with ease and peer-to-peer encryption. Let's go ahead and try to use it to share files across our network. Say, I have this file which I want to share to my phone. Firstly, you need to make sure that your device is connected to the mesh network. Now, back to the file that you want to share. If you right-click on it and click on More Options, you will find the option to share it to Tailscale. Here, all your connected devices will show up. So go ahead and choose the device that you want to share your file to. And just like that, the file will be sent over to the downloads folder of the device that you chose. Similarly, if I want to share files back from my phone to my PC, I just need to select the clips, click on the share button, and share them to the Tailscale app. Here, I will choose my Windows computer, and the videos will gradually start to appear in my downloads folder. This becomes really useful for me when I'm making content, because I gotta share videos and pictures here and there. This was everything good about a VPN, but just like every coin has two sides, VPNs also do come with some drawbacks. If your VPN is hosted in a different part of the world, your data has to go through the VPN server before reaching its actual destination. This extra step adds more distance over the network and hence more delay, which can slow things down. This can affect things like gaming, where your main focus is having a smooth, lag-free experience rather than privacy. While a VPN can help you access games that aren't available in your region, it will also cause delays, making the gameplay experience bad. A similar issue can arise when you are downloading large files, like game updates or big software packages. In these conditions, speed is your main priority and not privacy. A VPN generally slows down your speed, making the process take longer than usual. So there you have it. That's all for VPNs. Now go ahead and try setting up your own VPN and share it on my Discord. Let's have some fun with this VPN thing for a while. Also, make sure to use Zerops to host your servers and use my code StupidGeek to get $100 of free credit. That was it for the video. Thanks for watching.